So, the topic of this lesson is interfaces. In this lesson, I'll try to explain what are interfaces, what are they used for, and I'll show some nice things that can be done when using an interface. So first, what is it? An interface is an abstraction, essentially. It is a contract which tells what your function needs, what your class needs to do. I said that it's an abstraction, and that means that it doesn't have to have an implementation. It shouldn't have an implementation, and when you define an interface, all it has to do, all it has to have, is a bunch of functions without their implementation. So in this case, we have an interface iDamageable, and we have two methods, damage and destroy. So iDamageable is a contract that other classes will be able to implement, and by implementing this contract, they will have to implement how we damage something that is damageable and how we destroy something that is damageable. Note that an interface method does not have an access modifier. It's neither public nor protected nor private. But that's simply because that an interface is going to be used outside its bounds. It cannot be used internally. And for that reason, by default, it can only be public. That's why we don't need an access modifier for it. So we have two methods, damage and destroy. Let's try to implement them. The implementation of an interface is done the same as inheritance. All you have to do is to do the same as in inheritance. You have to write the inheritance sign in C#. It's double dot. How is it in English? Double dot.
What?
The sign after castle. The inheritance sign in C#.
Oh, colon.
Colon. Okay. So colon and then iDamageable. So this means that castle now needs to implement two methods, damage and destroy. I think the compiler will say that it doesn't implement those and will suggest that you do, so I'll just click the warning and implement the methods. So we have our castle, and now we need to say how we damage it and how we destroy it. So first, in order to implement the methods, we should take a look at our castle class. Our castle has towers and guards. It also has a gate and a wall. By default, a castle has no towers and no guards. So it has just an empty list of towers and an empty list of guards. It has to have a gate and it has to have a wall. So our castle has two constructors. Default one, which adds no towers and no walls, just creates an empty list of them, and a parameterized constructor, which adds our towers and guards from a constructor. Our castle also has a build method, and this build method is based on a builder pattern. So we can say build, and then we can keep stacking elements to our castle. Build, so it creates wall and a gate, the essential elements of a castle. then add tower, which adds a tower, and then add guard, which adds a guard. So those are the methods our castle has. And now we should try and implement the destruction and damage of a castle. So when we damage a castle, we should also damage all the elements that can be damaged within it. And if we go and look at the castle class, we see that it has destructibles list, which is damageable. So when we damage a castle, we should probably damage every single element that can be damaged within a castle. If we didn't have an interface damageable, we would need to say and call every single element in a class that can be damaged separately. But with an interface, we can do it all in one go. So let's try and complete the castle class so it makes sense first, and other classes that are related to it. This is bad. So first let's go to tower class to finish it up. Come on. Tower class, damageable. Please don't do that. So we need to say how we damage a tower. And how we destroy a tower. Also a castle, a gate, a guard. Please delete those. A tower and a wall, they all have HP, and we should also specify that they do have it. And I'll simply make a class which has an HP property, so we don't redundantly repeat ourselves. Hit points, I'll call it. Public HP, public float HP set and get, and each of those elements will inherit this class. So a castle has HP, a gate has HP, so does a guard, so does a tower and a wall. I could have chosen a different design and made hit points include the methods damage and destroy and make them virtual, but for the sake of this lesson I chose otherwise and made damageable an interface. So let's go back. We have our gate, and let's have them all implement the same thing. So I'll just copy paste it all. Tower, wall, implement everything, implementing guard, and gate, the methods, and all good. So if we go hit points, we have hit points. Okay. So when we damage a gate, we simply take away its HP by an amount, and if HP drops down to 0, it gets destroyed. And destroy will simply call a message gate destroyed. This will be a very boilerplate-ish kind of code, but we will make it unique for different classes in no time. So guard doesn't get destroyed, guard gets killed. Now tower also doesn't get, oh, tower, yes, tower gets destroyed. It's very similar. I'll just change the name. And wall gets destroyed as well. Now I think hit points, we have our class hit points. Well, it's good enough for now. So now we fixed those things, those other classes that we used, and when we add a tower or a guard, we add them to destructibles list. When we create a wall and a gate, we add them as well to destructibles list. And a gate. So we add both wall and a gate to destructibles list. We add a guard to destructibles list. We return this castle when we add a guard, so we can add more elements to it and keep decorating our castle. So, oops, I didn't want to run. Nope. When we damage a castle, say we first damage the gate, because if our gate is there, the gate and the towers and the wall. Yeah. So if the gate is still there, if the gate is still there, means HP is more than 0, and walls HP more than 0, and not and but or, because if either of those elements exist, that means we should attack and break through those first before we can go into castle and attack the guards. So if gate HP has, if there's some HP left for gate, wall, or towers, any of the towers, I'll do a quick link to select towers with HP. None destroyed towers is towers tower from towers. That's terrible and cool. From towers. Linku. Forgot syntax. I'll do for each and then convert it. Actually, this is even more efficient. So bool is any tower alive is by default true, and if I do a for each towers, why isn't it giving me autocomplete? Because it doesn't have underscore towers. Okay, towers. So for each tower and towers, if tower HP is less than 0 or equal to 0, we break the loop and set that tower is down. So towers are not alive. So if all of those are not alive, we can hit the guards and damage all guards. So guards, for each damage by amount, and if that's not the case, we deal damage to a construct. Also, I'll add one flag, is AoE. Nah, that doesn't make sense. I will not add it. Damage by amount. Let's refactor a bit. Private bool is towers alive. Are towers, or just towers alive? Is any tower alive? Okay, now we can move it here. Okay, so if any tower alive, if no tower is alive and those elements are down, we hit the guards, else we hit the rest. But that's not a good thing as well, because what I wanted to do here is I wanted to damage everything in general. Sorry about that, I'll just make it less complex. For each damageable element, in destructibles. So what I want to do here is to do a for each and damage everything that I can damage when I damage a castle. Imagine that it's an AoE attack and you target the whole castle with, let's say, a fireball, and it hits everyone with a certain amount of damage. So note that by using an interface, I no longer need to say that I'm trying to hit a specific tower, or all towers, or all guards, or gate, or a wall. They're all unified in destructibles list. So I can simply say damageable element dot damage and hit everything like that. So I'll just write a comment AoE and I damage it by an amount. So when I destroy a castle, I also destroy everything that's within it. So I do a for each and do the same essentially, except it says destroy. And that's it. Please delete all of those. Now all of those have the same. All good. So let's try and test what we wrote. Let's first make a class that will run our test. So lesson 3, I'll call it. It will have a method run. The class will be public. public void run, and let's see what it has. So we want to create a castle, and we want to build it with guards, with towers. So let's add multiple guards, multiple towers, let's say 4 towers. So we have 4 towers and 2 guards for our castle. This right here is a builder pattern. So we have a castle with guards and towers, and we can do something with it. So castle dot damage by an amount, by 10. Castle dot destroy not yet, later. So when we do damage to castle, we say that it's an AoE attack. Big AoE attack. An AoE attack, just an AoE attack. So an AoE attack and amount. That's the damage it does. AoE attack. Castle destroyed. Let's write here when we destroy the castle. And when we destroy a castle, HP is 0. When we destroy all others, HP should also be 0. And before we do anything, if HP is if it's less than 0 initially, we can only damage something that has HP left. If it doesn't have HP left, we ignore it. So we need this check, and it should be good. So guard, tower, and wall have those, and the gate, we didn't write a constructor for each, so oops. So let's say that by default everything has 100 HP. And let's go back to our castle class. So we destroy. Let's go back to our program class. We no longer need lesson 2, and let's try to test. So we create a lesson object. Let's include the missing namespace. I made a typo here. Let's clean it up. Nope. Clean it up. Okay. So let's go back to our program class and let's create a lesson object to test our program. So we create a new lesson and we hit lesson 3 run. So Control F5. We missed something. We did not instantiate something. It is in line 34, it says. Castle line 34. We do not instantiate a list of destructibles, apparently. So let's do it. We did it. Let's run again. An AoE attack 10. So we hit our objects by 10, and that got printed in the console. Let's go back to our run method. Let's try to destroy the castle as well in the end. So we hit our castle by 10, and then we say castle destroyed, wall destroyed, gate destroyed, guard killed, and then all the towers got destroyed, the guard got killed. So we just destroyed our castle. Let's try to switch this. When we destroy castle, HP is 0. If HP is more than 0, we attack it, otherwise we don't. Let's do it for the castle as well. So let's go to program, Control F5. So castle was destroyed, and along with it all the other things. And note that now we didn't hit the castle, even though we said that we would like to, because that condition that if it's already destroyed, we don't destroy it anymore. We can only hit something that has life left. So we just made an implementation, a basic implementation of an interface for destructible objects. The much better approach for doing this, now that I think of, would be simply having an abstract class and having some specific methods, but about that will be in the next lesson. We will refactor this class into something that is much better done. We will remove redundant code, as now we see that our gate implements damage and destroy methods. Maybe we want some default implementation. Maybe we want some specific implementation. Maybe our gate has statuses, like, let's say, a gate. We can do that actually now. So our gate is a construct, and so are towers, so our walls. So it's a construct. So let's make a class construct, which as well inherits a class the HP, hit points. This is a public class, and construct implements iDamageable because we can destroy something that we built. This goes for castle too. So when actually it's a composite object, so it won't go for castle. Anyways, so now we need to implement damage and destroy. So we go and I'll copy paste for now the same. Oops. I'll call them virtual. Remember that virtual methods can be overridden. So we changed their implementation in the inheriting classes. So we have our damage method and destroy method. We don't want this message, we just want to say HP is 0. We want this, yes, but we want some more logic. So we take amount away, we invert this to make it more readable. Now if we say if HP is less than 0, destroy. Else if HP is less than half of initial, so we will change our hit points class to add a new property called initial HP. And it will be for now the same hard-coded 100, but it will not change when we take away HP. So if current HP is less than half, let's say, of the initial HP, then we burn, initialize flames or something. So let's add a flag. Bool is burning. So when HP is less than half, something that has been constructed starts burning. So if something has HP under half and is not burning, we ignite it. And that means that our damage gets a multiplier, which initially is 1, but it changes to 1.5 after it's float. After we ignite. What is it, float? Yes, it's float. So we ignite. Okay. So we take away amount based on a multiplier because we have a status which makes the condition of a construct worse every time we damage it. Okay? And note that this does not exist in any class yet. So let's remove iDamageable and hit points from a guard. Actually, from a guard, that's fine. Wrong one. From a gate. Because now we have a construct which implements what we need. And we no longer need to implement those two methods. Because our construct class does that for us. Castle won't implement it because it's a complex object. A tower should implement it as well. Construct. And a wall, not implement but inherit it. That's what I meant. Construct. Now let's override our methods with some extra behavior. We would like to say that we damaged, to say what we damaged actually. So we would like to call console.writeLine wall is being damaged. Damage taken. And all others will have boilerplate code. So just copy paste 0 by a amount is what I meant, and we don't need this. Okay, now we do the same, very similar. Wall destroyed, so base destroyed. Okay, nice. And the same to tower. We damage a tower by amount, and on top of that we say that a tower is being damaged. Tower destroyed. And we override this. And we override this as well, since we add extra on top of the existing implementation. So wall has that, override wall, tower has that, guard doesn't have that, castle doesn't have that. So let's go back to our castle class, and all good, I think. Let's try to run. So let's hit Ctrl 5 and see what happens. Castle destroyed, wall destroyed, guard killed, tower destroyed, and last guard killed. Very similar, except now we don't need to have each classes implementing the same things. The gate, for example, doesn't, in this case, have any extra implementation, so it doesn't print anything when it gets destroyed, but the other elements do. So when we destroy, it gets that message printed. Let's make it a bit more interesting, and let's damage it multiple times. Let's go to construct to mark it if extra damage gets taken. Yeah, construct class 2, that's a horrible name. Construct. So we have our construct, and we ignite it, and we say how much damage gets taken. To remove the, we can also use reflection to remove the spoiler, like repetitive redundant code. So if we go to the tower class, we can delete everything now. We won't be needing any of it actually. We will do this all in a construct class. So when we deal damage to a construct, we do a certain amount of damage, and I will move this here and call it damage received is this much. So we take away damage received, and we also call say which class type, which class are we hitting. So we'll use a bit of reflection here. Type name, just name actually. So we're hitting a get type name. We're hitting this. So we can simply say console.writeLine and do a string interpolation and say that name took damage received. Damage. And we can say that it got ignited as well. So in ignite, we set multiplier and say the same. We will copy paste this and say console.writeLine name got ignited, applying, and I'll move this magical number private const float and call it burning multiplier will be this much. Use it here and use it here. So applying x times damage multiplier. Okay, and now we should also probably get name of this type in constructor, not every single time when we try to damage something, so we're more efficient. So we simply set the name private read only on string underscore name is here. Done. So if we underscore name, if we hit run now, we saw castle destroyed, guard killed, and so on and so forth. I probably missed something. Nope. Oh, when we destroy something, I didn't say that we destroyed, so I need to say that too. So let's do it. Console.writeLine our name is destroyed. Okay. Last but not least, let's run again. I forgot string interpolation here. Control 5. So now when we run, we see that each castle, wall, gate, guard, tower are destroyed. What else? So we changed our code quite a bit, and let's test one last thing, which is damage multiplier. And let's see how long will it take till our castle gets destroyed, and what happens. So we see that we get an AoE attack and everyone took 10 damage. Everyone took 10 damage. By the time the damage is 50, a wall took 10 damage, and then it got ignited because it's under 50 HP, under half of its HP. So it's taking twice as much damage. And in the sixth attack, we see it took 15 damage now, and it keeps taking 15 damage, and eventually didn't get destroyed. Oh yeah, it got destroyed. Wall is destroyed, gate is destroyed, tower is destroyed, tower is destroyed, tower is destroyed. And then we just see that we're taking AoE attack, but no damage is being done because everything is destroyed already anyways. So that's an example of using interfaces. So yeah. Now, do you have any questions? You can write anywhere you want if you have any questions, or say it if you do. A comment or so. So to wrap this up, interfaces are used for abstractions instead of implementations, and the main reason why we use them is because we want to be dependent on abstractions rather than implementations. Let me show you one trick. Imagine that you didn't know what an interface is, and you had a bunch of objects, like in this case. Let's go to our AoE damage method in the castle, and you see we did a for each for each destructible element. So we simply call damage to it. If you didn't have an interface there, you would need to probably have an enum, which would indicate what type of a damageable object is, and then based on the type you would need to have like a bunch of methods which would say how you try to attack and damage every single one of them. But that is not a good thing. That's an ugly implementation. It causes lots of redundant code, and it's all in one place. The logic for each of those elements is in one place. And like this, you have it all in one place, I mean in different places where it belongs, nicely separating responsibilities and giving you an opportunity, a possibility to abstract it away. So that's it for this lesson. In the next lesson, I will try to show tricks about interface and give some and teach about abstract class as well. So that's it for today.